That's fine. All right, so you guys, I said question number 2, we're gonna skip. It's the same thing. They want you to graph the lines and see what kind of lines there are. I'll do them later, but I'm just not gonna go over it now. I wanna tell you that we can actually figure out the number of solutions algebraically as well. Let's just pick one of these and try them. Which one do you guys wanna pick? 3, 4, or 5? Actually, let's pick 2 of them. So let's do question 3 and let's do question 5. In order for us to figure out the number of solutions, what 2 pieces of information do you need? Do you mind getting that? Because I just have my headphones in. Yeah, thank you. What 2 pieces of information do you need to figure out the number of solutions? If you look back at the chart, you're going to notice that we always talk about the slopes and we talk about the intercepts. So if I give you equations, and if you can calculate the slope of both of them and the intercepts, then you can compare them and see what kind of solution you have. So let's try that with question number 3. Okay, so what I'm going to do is I'm going to begin with equation number 1, which is 2x plus y is equal to 6. And in order to find the slope and the y-intercept, you can either make it into standard form or y is equal to mx plus b form. So what do you think is easier in this case? Yeah. Yeah, so it's going to be y is equal to negative 2x plus 6. And now we can easily see what is the slope in this question. Hamengi? Good. And what is the y-intercept in this question? Hamengi again? Yeah. So for the first equation, we calculate the slope to be negative 2 and the y-intercept to be 6. Sorry, thank you very much. Okay, let's do this. Yep, let's do the same thing for the second equation. It's going to be y minus 8 is equal to negative 2x. Again, for this equation, is it easier to change it to standard form or y is equal to mx plus b form? Madusha? Yeah, and you know what? It's really a personal preference. If some of you really like standard form, you can go ahead and change it to standard form. That's totally fine. It's whatever you want. Okay, so after doing that work, we change it to y is equal to negative 2x plus 8. We know that the slope is negative 2 and the y-intercept is 8. Are the slopes the same? Are the intercepts the same? No. So let's go back and see what scenario will our slopes be the same, but our y-intercepts be different. Which one of these scenarios does that match? Krishna? Yeah, so there's going to be parallel lines, and how many solutions will there be? None, because parallel lines never meet. So what was the question asking? It says analyze each system to determine whether the system has one solution, no solution, or infinite. And in this case, we just figured out that these are going to be parallel lines, no solution. And guess what? This is the same process you're going to use for all of them. So go ahead, and this is basically what your homework is going to be about. In case you're wondering, like, we're not really learning anything new. It's just the same stuff. If you look at the sheet that you're going to have for homework, I gave you a bunch of equations. For each of them, you're going to figure out the slope, the y-intercept, and then compare and figure out if the lines are parallel, coincident, or intersecting. I don't know why I wrote intersection lines. It should be intersecting. Okay, so go ahead and try questions 4 and 5 for each of the equations, figure out the slope and the y-intercepts, and then we can determine what kind of lines we have. I will do this as well. I won't talk about it because, so I'll just pause the recording. Thank you so much, Angelique. Actually, I won't pause the recording. I just won't say it out loud. But I'm doing the exact same process over and over again. Okay, so I'm basically going to talk to myself. But equation number 1, 3x plus y is equal to 1. I'm going to change this to y is equal to negative 3x plus 1. So the slope is negative 3. The y-intercept is 1. equation number 2. And I really encourage you guys, don't just copy the answers, try it yourself. Like I'm gonna have these up for a while. And you can also sometimes when something is already in standard form, it's just easier for me to not convert it and use the formula m is equal to negative a over b. Question?
So basically for the 3, you just like get it into y equals mx plus b and then find the slope and then find the y-intercept. And then like you just do it off like that.
Yeah, exactly. Just a little bit of rearranging. Okay, and I'll do question 3, sorry, 5 as well, and then we can confirm our answers after all that's done. -4. I'm going to change this one to y is equal to mx plus b form. That's always the easier form to change anything to. So if you're ever wondering which form you should be using, it's just always easier to change it to y is equal to mx plus b. But sometimes if the equation is already in standard form, I will just use negative a over b for those. Okay, also while you guys are working on those, I will put up the solutions for number 2. Yep. Intersecting different slopes. What's that? Not reverse, it's just different. Different slopes, different y-intercepts usually. Yes, sometimes the y-intercepts might be the same. So in, like I told you, like sometimes it could be different, or different, same. But like if as soon as you know the slopes are different, then right away you know they're intersecting lines. Yeah. So usually when I calculate the slopes to be different, I don't even need to go any further. Okay, I know you guys are probably wanting to see that answer. I'll bring that back after I do this one. I actually do all the examples, but I guess the practice would be good. Sorry, guys, just the internet just died, so I was just in the middle of this question.
So when every number line is different.
Yeah.
And after the once it's dense, it means like everything is the same, and then for parallel states go for different lines.
Exactly. All right, you guys, for example number 4, did you get for the first equation, the slope is -3 and the y-intercept is 1? And then for the second equation, did you get the exact same thing? So what kind of lines are these? Janahan? They are coincident lines. Yep, coincident lines. And how many solutions would there be, Janahan? Yeah, there are infinite number of solutions. I'm just going to use a short form for solutions, which is SOL, comma N. For the third one, did you get the first line to be slope is -2 and the y-intercept to be 4? And then for the second line, the slope is -0.5 and the y-intercept is 3? Yeah, let me know. I may have made a mistake. So if you got something different, let me know. What kind of lines are these if the slopes are different? Yep. Yeah, and you guys, if as soon as you find the slopes to be different, you don't need to go any further. If the slopes are different, they're going to be intersecting. So I know right away these are intersecting lines. So how many solutions are there? There's going to be one solution.
How would you get for the slope? How do you get -1?
Because did I write it right? A value is 1 and the B value is 2. So it's going to be -A, which is, oh, that's fine. You should have still gotten -0.5. Just
I did y equals -2 and move it over, and then plus, oh wait, no, that's not right. Oh no, so I did 2y equals x and move it x.
-x.
Oh,
All right, and then let's go back to this example. I just quickly did it. I've noticed my slopes are -1 and my y-intercept is 3 for both of them. How do you show that? You really can't. It's kind of like two lines that are on top of one another. I just kind of made it into like this sparkly galaxy line. But the main point is, what kind of lines are these? Yeah. Yeah, these are going to be coincident lines. And how many solutions for coincident lines? Coincident, and so there are an infinite number of solutions. Good. I'm really silly because I started the recording for this and then I stopped it, and so it's going to be in like 2 different recordings. But let me just go over your homework. So what did we learn in this lesson? We learned number of solutions. There's no new math. We haven't learned any new math. We're still just finding the slope, finding the y-intercept. Now we're just comparing them. The key takeaway from this is you can first find the slope. If the slopes are different, it's going to be intersecting. If the slopes are the same, then you have to go an additional step and find the intercepts and then compare them. If the intercepts are different, they're parallel. If they're the same, they're coincident. Your homework for this, no, you don't have to worry about any textbook questions. I think as long as you do handout this one right here, it's handout B. For every single one of these questions, you're trying to find the slope. And then if you need to, you're going to try to find the intercept, and you're going to try to figure out if they are parallel, coincident, or intersecting lines. And all of the solutions are at the bottom. Okay, so now I can go ahead and stop the recording.